Greetings, my name is Gabriel A. Garcia, and I'm a student at the University of Idaho in Moscow, Idaho. I'm going to present my project titled Biochar as a Compost Amendment, which I worked on during my junior year, and which was funded by a $2,700 grant from the University of Idaho Sustainability Center. The project seeks to answer 3 questions about biochar, which is charcoal used for soil improvement or agricultural purposes. The first is, does adding biochar to a mixture of campus food and dairy wastes increase the rate at which they decompose? The second is to determine if biochar amended compost contains higher levels of agronomically important elements such as nitrogen, phosphorus, and potassium than the control. And lastly, can a material with a similar particle size, such as pumice, have a similar effect on the composting process? To answer these questions, I set up 3 different compost treatments, each in their own 90-gallon tumbling composter. All 3 treatments contained 100 kilograms of compost feedstock, which consisted of 66.5% shredded campus food waste, 3.9% campus dairy cattle manure, and 29.6% Douglas fir wood pellets on a dry weight basis. The carbon-to-nitrogen ratio of this mixture was found to be about 25.6. Treatment 1 served as the control and had no amendment added. Treatments 2 and 3 contained an additional 10% by dry mass pumice and wood biochar respectively. The 3 treatments were located in an unheated hay storage building at the campus dairy. A representative sample of each treatment was submitted to the campus analytical science lab and was analyzed for nitrogen, phosphorus, potassium, organic matter, and pH. The 3 treatments were then monitored about weekly for mass, temperature, and pH for a period of 114 days from December 8, 2011 to March 29, 2012. Mass was measured by wheeling each composter onto a digital scale, and pH and temperature were measured with a Hanna portable soil pH electrode. Because of low ambient temperatures, blankets were laid over each composter on the 11th day of composting to prevent freezing of compost and to encourage decomposition. An equal length of roof and gutter heating cable was added to the inside of each composter on the 64th day of composting in addition to the blankets. Unfortunately, due to the cold temperatures, the compost never reached full maturity. At the end of the experiment, another representative sample of each treatment was submitted to Analytical Science Lab for the same analysis. Also, since no treatment reached truly thermophilic temperatures, we decided to have the treatments analyzed for any fecal coliforms that may have made it through the composting process.
Following footage shows and explains some of the methods I used at the beginning of the experiment.
I'm going to start my first shredding of food waste for the compost experiment today. This is some of the food waste that I'll be shredding today. And I'm going to use this electric chipper shredder to shred the food waste. I'm going to collect it in this green bucket right here. And a few bottles of water to clean out the chipper shredder when it gets plugged up. And the shredded food waste we brought over here at the back of this large building. It'll be placed on these pieces of ag bags that I found to protect against water getting into the food waste and leaching out nutrients. Here's some of the garbage I've collected on my first day of shredding food waste. Here is all the food waste that I've shredded so far. It's about 84 gallons total. Most of it's been out here for about 2 weeks, but it's been cold enough that I think it hasn't decomposed very much. I haven't mixed it up yet, but I'm going to mix it up as best I can and then add the appropriate amount of manure and wood pellets to it so that there's a 3-to-1 carbon-nitrogen ratio. This is the food waste after I've mixed it with wood pellets and manure. The manure is sitting on top. I haven't mixed it in yet. And after I mix in the manure as evenly as I can, I'm going to transfer it to this inside of this building in the front. I'm going to fill composter 1 right now with this bucket, 20.1 kilograms of food waste. Just finished putting together these new bases because yesterday, after putting in about 70 kilograms of material into composter number 1, found out these yellow scooter bases didn't work very well, so I got these other ones, and I think they're working much better. And I'm going to add just 100 kilograms of food waste and material.
The results show that the biochar treatment is slightly warmer and loses mass more rapidly during the warm phase of composting, which is chosen to be 15 degrees Celsius and above. However, these effects weren't observed during the cooler or less than 15 degrees Celsius phase of composting. The chemical results show that the biochar treatment contains roughly the same amounts of plant-available potassium, phosphorus, nitrates, nitrites, and total nitrogen. However, it contains about half the ammonia concentration.
This may be due to
Slightly basic pH of the biochar treatment, which results in more ammonium or NH4 plus ions being deprotonated to the volatile NH3 or ammonia gas, which leaves the compost. Since the total percent nitrogen and nitrate and nitrite levels are about the same across all treatments, organic forms of nitrogen must make up for the lack of ammonia in the biochar treatment. The fecal coliform analysis returned negative results across all treatments for the presence of E. coli and Salmonella. Treatment 2 contained by far the highest concentrations of Enterococcus spp suspects and was the only treatment to contain non-lactose fermenters. This may be due to treatment 2 being the most immature, as is shown by its clumpy appearance. So in conclusion, amending compost with biochar may help speed up the warm phase of composting of University of Idaho food and dairy waste, and further analysis will need to be done to determine if biochar helps retain nitrogen and other nutrients during the composting process.
I'd like to give a large thanks to the University of Idaho Sustainability Center for funding and encouraging the project, Dr. Aurelio Briones for advice and guidance, Char King International of New Plymouth, Idaho for donating the biochar, and Christopher Curry for lab assistance. Thank you.